Now see here Newton's law of gravitation. See here, in the universe any two bodies which have masses are attracted by gravitational force towards each other. It means if there are the two bodies like this of masses m1 and another is of mass m2, these two bodies are attracted towards each other with a force. That force is known as gravitational force. This force may act between any two bodies having masses, maybe the planets or the moon or the satellites, maybe the planet and the sun, and maybe the planet and any other object. So, that force m2 is applying the force on m1 and that force is acting to this side, that is here called F12, force on 1 due to 2. Similarly, m1 is applying force on m2 and that is called here F21, force on 2 due to 1. These are the mutual forces. Suppose the distance between the centers of the bodies are, so we can write magnitude of F12 is equal to magnitude of this F21 is equal to F. All these forces are called gravitational forces here. So, F is here the gravitational force which is directly proportional to the product of the masses and inversely proportional to square of the distance between them, and this force acts along the line joining the centers of the two bodies. So, F is equal proportional to m1 m2 upon r square. That can be written F is equal to G m1 m2 upon r square, where G is called universal gravitational constant, and the value of G is here 6.67 into 10 raised to power minus 11 Newton meter square per kg square. So, this is the value of gravitational constant. This value remains constant whatever the pair of the two masses you are taking. That is why it is known as universal gravitational constant. In the universe its value remains same everywhere. Now, see here, as I have told you, this gravitational force is here the mutual force acting along the line joining the centers of the two bodies, that is also considered as the central forces. Another one also, this gravitational force does not depend on the mass, so it does not depend on the medium existing between these two masses. So, this is about Newton's law of gravitation, and this is in actually here scalar form. So, this is the scalar form of the Newton's law of gravitation or the gravitational force. Suppose you have got two bodies here. So, now actually I am discussing Newton's law of gravitation in vector form. So, if you are using here the vector form, obviously you have to use direction. Suppose there are the two bodies like here the masses m1 and another one is of mass m2. Both are joining by this line, that is a distance r is here, and F12 is acting to this side and F21 is acting to this side. You can write here F12 is equal to G m1 m2 divided by here r square. Force is going from this side, so we can write here r12 unit vector, and r12 unit vector is actually from 1 to 2. Its direction is from 1 to 2. Similarly, we can write here F21 is equal to G m1 m2 divided by r square, and now this is acting from 2 to 1. So, we can write here r21 unit vector, and this direction is from 2 to 1. Now, we can see r12 unit vector is equal to minus r21, they are opposite in directions. So, we can actually write F12 is equal to minus F21. So, here actually Newton's third law of motion. So, we can use this concept. So, we have given the direction here, we have just put here the unit vector which is making this quantity as a vector here. So, this is the Newton's law of gravitation in vector form.